I really love understanding something I didn't know before. If it can be applied, that's even better, but I still get a buzz out of learning something. We're wet surface scientists, so we look at molecules sticking on surfaces. There's a whole range of applications, everything from making ice cream to lubricating wind turbines. We're an experimental group, but we do a lot of work at international facilities all over the world. So often our group will head off somewhere, do a couple of days experiment, and then perhaps go skiing if they happen to be in the French Alps at that facility. They're mainly additives used to control, say, friction or anti-corrosion additives. They look a bit like tadpoles. They have a head group that's polar and a long dangly tail that gives them oleophilic properties. We have a lot of real-life applications. A lot of our work is sponsored by industry, and we really like solving things that have a practical need. In recent months, of course, we've been involved in some anti-coronavirus work. So as surface scientists, we care about how molecules stick on surfaces, and actually how the virus sticks on surfaces is a key way it's transmitted. So we have a project just starting now, trying to see how to catch the virus and how to stop it working, ideally kill it in speech marks. It's just another example of surface science for us. So the idea is we have fundamental tools, nice experimental methods that can be applied to a range of systems. And so that's one we're just kicking off with now. We have a range of other projects, particularly one looking at corrosion. So it's a very long-standing problem, going back many, many centuries, but still a problem. And so we want to see what happens on a very small length scale at the corroding surfaces, and how the molecules we add actually do what we want them to. And it turns out they don't behave how people have thought they do. And so by understanding how they really behave, we can enhance them and get better ones to work. My first experience of this world was actually through Oxford. So I have to admit, I confess openly, my first 3 degrees were at the other place. And in fact, I came here for my first postdoc. So it wasn't such a surprise coming to the Oxbridge world at that point. But again, I really like it here. It's a wonderful place to be, very unusual. I was the first person in my family to go to university, and so yes, it was a bit of a surprise when we went there, but it was, everyone's very welcoming. It's always been enormous fun. I've never really felt out of place. In terms of our activities as a group, we often go out for teas. So there's some very nice cafes in Cambridge, and so the whole group will go to Brown's or Fitzbilly's and just have buns and tea and chat about things. Occasionally we go to other places. So we had a trip to the Wren Library in Cambridge to go and see some of the letters from Faraday. In fact, including when they first used the words anode, cathode, anion and cation, the first time they were ever used in that context. We also went to the lab of molecular biology, a very famous lab here with a huge number of Nobel Prize winners, and we showed the group round. And on the way back on the bus, I said, well, what do you think of that? And they said, it's great, they've got a cafe that does cook breakfast.